aware with the more concept calculations that we have been doing for the past week. And I hope by now you'll be able to understand or calculate somewhere, either in the exam or in the test that you're going to write on case. Exactly. Where you have problems, talk to your best friend to help you understand. But from my own understanding, I think you guys have understood that topic and are able to answer questions, isn't it? Right?
Right.
Okay, so today I want us to look at something different away from those calculations. Though we're still going to be dealing with the calculations, but it will be something different from the other previous calculations that we're dealing with. Exactly. They're simply just chemical reactions. Now, for a chemical reaction to take place, we understand that we're supposed to have things that should react. And when those things react, we should be able to produce something, isn't it? Okay. And those things that are supposed to react together for us to have a product, they're simply what we call reactants or reagents, isn't it? So in most chemical reactions, or in all the chemical reactions, let me put it that way, we have two reactants or two reagents that should react together for us to have a product. But then, these reactants that should react together for us to have a product cannot always, or it does not mean that all these two reactants that we have should finish at the same time. Finish at the same time. For example, if we have a reaction X plus Y reacting together for us to produce X, Y. This is one reactant and that is another reactant. Then the XY that we have is simply a product, isn't it? Okay, so now these two reactants are not going to deplete or finish at the same time in a chemical reaction. Is that clear? Now, if X and Y react together and it happens that X, reactant X, finishes first or is completely depleted in a chemical reaction, we simply call that type of a reactant as a limiting reactant. Limiting reactant or limiting reagent. We have two reactants that are reacting, but if the other one finishes fast in a reaction, even before we even have our product, we simply call that type of a reactant as a limiting reactant. We are calling it a limiting reactant because it is simply limiting the reaction from proceeding. Is that clear? And once the one reagent finishes, it will simply also mean that we are not going to have more products. No more products will be formed in this reaction. Is that clear? Then, the other one that remains unreacted after the limiting reactant has finished, it is simply what we call the reactant in excess. Are we together, Lisa?
No.
Huh?
No.
Okay. We are talking about simply chemical reactions. All these things that we have been dealing with as we've been doing our reactions. Because if you check the things that you have been calculating, most of them would involve chemical equations, isn't it? And we know that for us to have a chemical equation, we simply need to have reactants as well as the products. Is that clear? Now, I'm saying that in most chemical reactions, we normally have two reactants, isn't it? For example, or let me not say X and Y. For example, if we have magnesium reacting with hydrochloric acid, these two we are calling them what? Reactants, isn't it? Or reagents. When magnesium and hydrochloric acid react together, what are the products? Magnesium chloride and hydrogen gas. Those are the products when these two reactants react together. Now I'm saying in most chemical reactions, these reactants do not always finish at the same time in the reaction. Do you get my point? The other one will either finish first, then the other one will remain in the chemical reaction. Now I'm saying if it happens that in this reaction, magnesium finishes first or is depleted first as the reaction is proceeding, we simply call this reactant that has finished first as a limiting what? Reactant or a limiting reagent. Is that clear? Now, if this limit, we are calling magnesium a limiting reactant because it has finished first in a reaction. Therefore, it means that it is going to disturb the reaction from proceeding. We are no longer going to have products being formed because one of our reactants has finished. Then the other reactant which remains in excess or which remains unreacted in the reaction, it is simply what we are calling the reactant in excess. And therefore, the limiting reactant or the limiting reagent is the one that is responsible for the production of our products. Is that clear? So once it finishes, it means that we are not going to have products being formed because hydrochloric acid will not react on its own for us to have magnesium what? Chloride. So that is what happens in a chemical reaction. Not all the reactants will finish at the same time for us to have products. It's either one will finish first, and the other one will remain in excess. And the one that finishes first is what we are calling a limiting reactant, a limiting reagent. Then the one that remains unreacted, it is what we call the reactant in excess. So apart from dealing with calculations involving concentration, number of moles and all those, there are times when you'll be asked to calculate the mass of the limiting reagent. Or there will be times when you'll be asked to determine the limiting reagent in a chemical reaction. Okay? How are you going to determine the limiting reagent in a chemical reaction? I have this example. So, magnesium and oxygen react to form magnesium oxide according to the equation below. So we have magnesium and oxygen reacting according to this equation. And we are told that if 6 grams of magnesium and 2 grams of oxygen are available for a reaction, determine the limiting reactant. Then B, what amount is in excess? Okay, what amount is in excess? Then C, you calculate the mass of magnesium oxide formed. Stop talking, I will give you a chance to calculate. Alright, so that is the question that we have concerning limiting reactants or limiting reactions. So how do we go about? In case you were not given this equation, you were supposed to formulate an equation for this statement above. Okay? Alright, so if the first thing that we're supposed to do is balance the equation. So how is our balance equation going to look like? I added 2 where? Joseph. Okay, so always remember to balance your equation. So how is our balance equation going to look like? So magnesium reacting with oxygen. Okay, is that correct? It is, right? Okay. So this is our balanced equation. So we have, according to the stoichiometric ratio, if you remember what we were dealing with last time, it means that 2 moles of magnesium is going to react with how many moles of oxygen? 1 mole of oxygen to produce how many moles of magnesium oxide? 2 moles. Okay, good. So this is the balanced chemical equation for that reaction. Okay, we have not yet answered our question. We are told that if 6 grams of magnesium and 2 grams of oxygen are available for this reaction, determine the limiting reactant. What do? If you check this statement, we have 6 grams of magnesium and 2 grams of oxygen. Magnesium and oxygen are the reactants, isn't it? Yes. Okay, have we been given the mass for magnesium oxide? No, we haven't. So, when you're faced with such a question, where you're given the mass for the 2 reactants, what you should do is, the second step now is simply to convert the given mass to the number of moles. Alright. So now, how do we do that? We have 2 substances, and for each of these substances, we have been given the mass. So what you simply do is, pretend you have not been given for either of them. Is that clear? So what we are simply going to do is, we are dealing with magnesium and oxygen, and 6 grams of magnesium has been given, as well as 2 grams of oxygen. So we're going to pretend at this point that, let's say we have not been given the mass of what? Of oxygen. So for us to convert that mass to number of moles, it means that if we ignore the oxygen, we are simply just going to remain with magnesium, right? Okay, so how do we convert the 6 grams of magnesium to number of moles? Yes, Eric?
I think we use the formula N equals mass over molar mass.
Okay, so mass divided by molar mass. Okay, what is our mass?
6 grams.
6 grams. Okay, and our molar mass? What is our molar mass? 24. Okay, the mass of what? Magnesium. Alright. Can someone do this calculation for me? What are you finding? 0. What? 0.25. Okay. 0.25 what? Moles of magnesium. Alright. So, if we have this number of moles for magnesium, we are simply going to determine the number of moles for the unknown, which is what? Oxygen. How do we do that? We are simply going to use the mole ratios. Is that clear? Yes. So, we're going to get the mole ratio between magnesium and oxygen. So, what are those mole ratios?
2 to 1.
Huh?
2 to 1.
2 to 1, isn't it? Okay, 2 to 1. And how many moles of magnesium have we calculated? 0.25. Okay, 0.25. Do we know the number of moles for oxygen? No. So let's see. Okay. When you first multiply here, you're going to have 2x is equal to 0.25. Divide both sides by 2. What is your x? 0.1 moles of oxygen. Okay, so these are the number of moles for oxygen. But we have not yet answered our question. Our question is for us to find or to determine the limiting reactant. Which reactant between magnesium and oxygen is going to finish first in this reaction? So when you reach at this point, you convert this number of moles back to mass. Is that clear? Okay, and how do we convert the number of moles to mass? What do we do? Come on, guys. These are the things we were doing last time. Java. The same formula, isn't it? Okay, we're using the same formula, which is number of molar mass. But our interest is to find the mass. So therefore, mass is equal to number of moles multiplied by molar mass, isn't it? What are the number of moles? 0.125. And the molar mass for oxygen? 32. When you do your calculation, 0.125 multiplied by 32, what's the answer? It is 4. 4 what? 4 grams of oxygen. Okay, 4 grams of oxygen. So for us now to determine the limiting reactant, what you simply do is this. You compare the calculated mass with what was provided in the question. Is that clear? Okay, so according to our equation, or according to our reaction, magnesium was reacting with oxygen, isn't it? Okay, and 6 grams of magnesium was provided to react with how many grams of oxygen? 2 grams. 2 grams of oxygen. So this is what was provided. But what exactly is required for this reaction to go to completion? Magnesium is reacting, of course, with oxygen, and 6 grams of magnesium was supposed to react with how many grams of oxygen? 2 grams. According to the calculated 4 grams, isn't it? Okay, so 4 grams is what is required for this reaction to proceed. So 6 grams of magnesium is supposed to react with 4 grams of oxygen. But what was provided, or what was given in our equation, is that 2 grams should react with 6 grams of magnesium. So between magnesium and oxygen, which one is the limiting reagent?
4 grams of oxygen.
Which one is going to deplete first? Oxygen is going to finish first, isn't it? Because it is supposed to react 6 grams of magnesium and finish faster than what was going to be required. Okay, so you simply compare the mass of what you have calculated for. What you have calculated for is 4 grams, but what was given was less. So because this was less, it simply means that it is going to finish fast in the reaction. It was 2 grams which was provided for us to proceed this reaction, but in normal circumstances, it was supposed to be 4 grams which was supposed to be required for it to react with 6 grams of magnesium. Therefore, our conclusion is that oxygen is the limiting reactant. Yara fast in reaction because it was less than what was supposed to be required for the reaction to